Ibrahim, can you hear me?
Yes.
Okay. How are you?
Good, thank you.
How was your week this week? Busy or
Not as busy. I did finish my homework though.
yeah. I, there's some progress. In the previous one, I think you got 44. Now I just check your answers and 61. Okay, Ibrahim. So we are going to discuss in this class the question that your answers were not correct. Okay. And after that, if you have more time, we'll practice new paper. Okay, Ibrahim.
Okay.
All right. Today, 9th of February. Okay. Let's start. The first question is question 8. Read the question.
Okay, let me get to the tab. Question 8.
Can
The
you see
difference
it?
be the
Mhm.
difference between two whole numbers and 2022. The difference between two whole numbers is 2022. The quotient of these two numbers is 7. Find the sum of these two numbers.
So the difference between two whole numbers, right? Suppose that is P minus Q, right? So that's equal to 2022, right? The quotient of these two numbers is 7. So that means the quotient of these two numbers means division. Why when you divide P by Q, you get 7, right? Find the sum of these two numbers, right?
Yeah.
So that's it. Now from the
Oh,
second question,
I think I know what I got wrong.
what is that?
Like I found the two numbers, but I did the bigger one. I forgot to add the smaller one to it. That's
Oh,
why I got 2,359.
I see.
Yeah. So it's 2,696, right?
Yeah. P is equal to 7Q. So 7Q minus Q is equal to 2022. And now if you divide this by 6, right? 2022 divided by 6. 20 divided by 6, it is 3. 22 divided by 6, it is 6. Again, it is 3. 42, 7, right? If Q is equal to this, then P should be equal to 7 times 3, 3, 7, which is equal to, and 6 and 7, what is that? 7 times 7, 49. 7 times 3, 21, 25, and 21, 23, right? So if you just add this, you will get 7 plus 9, 16. 3 plus 5, 8, and 9. It is 6 and 2, right?
Yeah.
Okay, good. I mean,
That makes sense
it's a
now.
small technical mistake. It's fine. But it's the second time you took. But I wonder in the first one you did the same mistake or not?
Um,
Hmm?
I deleted the tab so I can't see the answer, so I couldn't see the answers while I was doing it again, and I can't get to it because it just shows the entrance screen to it. Yeah, so I'm not sure.
Okay, no problem. 13A. 13 question. Question 13. All right. Read the question.
In how many ways can 30 be expressed as the sum of two or more consecutive whole numbers?
Is the sum of two or more consecutive, right? Consecutive whole numbers. How many did you find?
Two? Yeah, it's three, right?
It's
On the
even
last,
number, so that's not possible to express this as a consecutive two numbers, right?
yeah.
But how about three? It is yes, right? If it is three, it will be like this, right? N minus one, and it is n. It is n plus one. So the sum is equal to 3n. That's equal to 30, right? It has solution. So it is possible, right?
Yeah.
So that's one. Okay. Number two, how about four?
Mm. Well, you can also do, I think you can do five though, right?
Yeah.
I don't think four
I
is,
think you found only 3 or 4 because your answer is, uh, what is your answer? Question 14. Your answer is question 13, right? Your
yeah,
answer is 2. But did you solve it like this, Ibrahim? The first case, okay. The second case is 4. If it is 4, we have n minus 1 and n, and here we have n plus 1. It should be n plus 2, right?
yeah,
And just easy to calculate this. Here, this one is n, 3n, 4n. So 4n plus 2 is equal to 30. And also it has
yeah,
solution, right? N is equal to 7. So that means it's possible. That is 5 and 6 and 7 and 8, right?
yeah,
So that's also possible. And how about if it is 5 consecutive numbers? Also it is possible. N minus 2, n minus 1, and here we have n plus 1, n plus 2. And the sum of these numbers is equal to 5, and that's equal to 60 and 30. 30 is divisible by 5. Also the solution. So that is, what is it? 6 minus 2. It is 4, 5, 6, 7, 8, right?
yeah.
And now you see here the smallest number is 4. And how about next one? If it is 6, right?
Mhm.
I can write actually just like this, 6n. So that is n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. The sum of the first 5 numbers is 5 times 6 over 2, that's 15. That's equal to 30, right? So actually this doesn't have solution, right?
Yeah,
And how about 7? If it is 7, we know that n minus 3, n minus 2, n minus 1, n plus 1, n plus 2, n plus 3, n plus 4, right? So which is 7n. Simple. It's just 7n is equal to 30. It doesn't have solution. And others are not possible. They are not whole numbers. So we have only 3. 1 and 2 and 3, right?
yeah,
So it should be 3. You found, I think, only 2, right?
yeah.
Okay.
Well, I think on the last one I did get this question right. I have no idea how I got it wrong this time.
Hmm. I mean, important thing is if you use these methods, you can see exactly it has how many, there are how many ways that we can write 30 as a sum of 2 or more consecutive numbers. But if you just guess, still you may not be sure. That's the power of algebra. When you solve questions algebraically, you are 100% sure it's a solution or not. It has this many solutions or not. All right, let's continue. 13. How about 14? Try again, Ibrahim. Can you try this again? Let's see what you get this time.
Okay.
Yes, Ibrahim, why is it taking so long?
Yeah, I just don't know how to do it.
Look, Ibrahim, I'll just do some, use this logic. If $100 is shared by two people, right? One person, that
Hmm.
guy gets $100, right? He did some business and the whole profit is that's $100. And if it is by share, if $200 shared by two people, each person gets less than 100, right?
Yeah.
If four people, eight people, 10 people, when the number increases, right? Each share also decreases. Okay. Now we are talking about three numbers, A, B, C. They are whole numbers. Whole numbers means that what is it? 0, 1, 2, 3, 4, 5, right? So that means that actually you are dividing on the right-hand side 1 by something which is greater than 1 because B plus 1 over C, that is greater than 1, right? So if I write this 25 over 17, right, as a whole part, I can write this 1 plus what is this? 3, 8 over 17, right?
Yeah.
So that means that from this observation, I can see that A must be equal to 1, right?
Mm.
Okay, now next one. And if you remember multiplicative inverse, what is the multiplicative inverse? Or in math, we call this reciprocal, right? Of AB, it is B over A, right? So that's equal to 1. So that means that instead of this A over B, I can write 1 over B over A, right?
Yeah.
Okay. Now look at this 8 over 17. Each time I'm going to write this fraction as a whole part and fraction part. 8 over 17, I can write it as 1 over 17 over 8 equals 1 over 17 over 8 is, what is this? It is 1 plus 9 over 8, right?
Oh,
And again, this 9 over 8, I will rewrite this. I have here 1 plus, what is 9 over 8? 1 over 8 over 9. No, 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 no. Wait. No, 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 no. We made a mistake here. In 17, we have two eights, right?
mm,
I can write this 2 plus 1 over 8, right? I
yeah.
think that's it. We don't have to continue here. So from this, you see, what is A? A is equal to 1. What is B? B is equal to 2. What is C? C should be equal to 8, right? Right?
That makes sense.
Now we have A plus B plus C. A is equal to 1, B is equal to 2, C is equal to 8, which is equal to 11. You see more different questions. Again, here, it's about whole numbers, but you should understand two, three things here. That's why it's challenging. It's a bit, if you do not approach the problem from different perspective, you may not understand this. Now, if you try, to express the right-hand side as a single fraction, it gets more complicated. Okay, some stuff in math, you should not do anything. Just look at this and try to read how actually they are related to each other based on what logic. Anyway, let's continue. It's clear. So next question is 15, 14, 15. Read the question.
5 girls each prepared one gift for a party. How many ways can these 5 gifts be distributed among the 5 girls so no one receives her own gift?
In math, we have, permutation, and we have another thing we call this de-arrangements. And just right here, also you can have a look when you have time. Okay. Second. All right. Uh, if you just try to do this without using a formula, it's going to take a long time. Okay. Maybe for one small number we can, but for your future reference, okay, it's a new concept for you if you have never seen. So the arrangement, we have arrangements and we have the arrangements. But in this question, if you read this, it's saying that five girls, right? So we are talking about five girls. Let's say first name is Annie and Benny, Cindy, Danny, and Emma, right? Five girls. So each prepare one gift for a party. How many ways can these five gifts be distributed among the five girls so that no one receives her own gift? Okay. So in this case, in this kind of questions, Ibrahim, we use this format, the arrangement. That means that distributing something, exchanging among a group of people. What is the condition here? No one will receive his or her own gift. Okay. So can you just write it down, and after that you will use this to solve this question. Done?
Almost. I'm done.
Okay. Because this formula you may forget, Ibrahim, but at this you have some idea. We have this kind of concept. Okay. And
Okay.
what is this? You know how to solve this kind of problem in the future if you have this. Like, for example, in a neighborhood, there are 10 people. Everybody has their own house. How about if you rearrange their houses so that nobody will stay in their house anymore? Okay. And how many different arrangements we can make? It's also daily life or problems. So now let me just write the formula one more time. So the arrangement, we call the arrangement, right? So that's equal to in simple notation, that is n factorial times, and here we have sigma, right? Here we have uh, n factorial and sigma here. So sigma means a summation. This k is changing from 1 to n. And what else do we have here? Here we have -1 to the power of k over, and here we have k factorial. Okay, but actually, if you just write a long one, it's easy to remember. Here we have n factorial and open parenthesis. When k is equal to 1, -1 actually should start with 0. It should start with a 0, right? It should start with a 0. This should be 0. When it is 0, -1 to the power of 0, and the 0 factorial, that is 1. And after the plus, minus, plus, minus. So the next one is minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus dot dot. In our case, we are talking about 5 people, right? So that means that we have 5 girls. So in our case, n is equal to 5. So when n is equal to 5, if you just calculate this D arrangement here, sorry. So this must be 5. D5 will be equal to, I have here 5 factorial times, open parenthesis, 1 minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial. Yes.
Isn't this just a subfactorial?
Hmm?
Isn't this just a subfactorial?
What?
A
Sub?
subfactorial?
What do you mean?
No, like a number with a instead of a exclamation mark in front of the number, it's behind it. Yeah, you can
Uh-huh.
search it up. Yeah, because the formula is the same.
Ibrahim, are you asking a question or you're commenting? I don't understand. Can you say
Yeah.
again? Are you
Is
talking
this
about this
just a
formula
subfactorial?
or
No, because I think I recognize this formula.
okay?
Yeah.
So you saw this before?
No, but like the formula looks similar to the subfactorial. So I'm asking if it's just the same.
Okay, what is the name of the formula that you saw before? Do you remember its name?
Subfactorial.
Subfactorial.
Yeah.
Subfactorial. What is that? I
Yeah,
never.
because the formula looks very similar.
Subfactorial. Let me just, not Copilot. Just one image here. Yeah, it's the same thing.
Oh, thanks.
So subfactorial, maybe it's another name. The subfactorial formula is used for, oh, here we have n factor in front of this n, right?
Yeah.
And I remember now. I see. Yeah. So that's used for subfactorial. Is in front of this n, that's n factorial times k is equal to 0 to n, negative 1 to the power of k, k factorial. Yeah, that's right. Subfactorial. I remember. Okay. So the subfactorial formula actually is used for de-arrangement. Also for others, it may be used. Usually factorial is used on the purpose of compact notation. Sometimes we have long expression and mathematicians introduce, short notation. Everything's actually symbols, right? So
Yeah.
addition is symbol, multiplication is symbol. Actually, addition is very basic fundamental operation. But if we have a plus a plus a, we just write it as 3 times a, right? 1 times 2 times 3, we just write it as 3 factorial, right? And also this one is used somewhere here. That's why mathematicians introduced this notation. So we should understand this as subfactorial or the arrangement. Very good, if you remember this. What is 5 factorial?
No, that's 120.
It's 120, right? Okay. So the first one is 120 minus 120 divided by 2, it is 60. Plus this one, 4 times 5, it is 20. Minus only 5 left, it is 5. Plus 1, right? So which is equal to the 60, 80, 76. So that means that there are 76 different ways we can arrange these gifts so that nobody will receive her own gift. But then with the 6, we have a lot of combinations. 7, a lot of combinations. That's an interesting question. Okay. But if you ask without using a formula, can we calculate this? Yes, it's very long and risky. If you just miss one combination, you will get wrong answer. That's why we need formulas. Sometimes, now if you see this, you can remember this. Next time, if you see similar question, you can remember much better. At least somewhere in your brain, right? I have such way formula. I should use this in such situation. And we call this knowledge, right? Okay, let's continue. Well, good. Next one is 16. How many did he count here? 24, right? I think.
Yeah.
Okay, how did he count? I am just interested in your methods. Using what methods?
I know there's a method, but I forgot what that method was, so I just counted it manually.
No, okay, we count it manually. I don't think if there's we have different way, but did you count like this? First, make a table, okay, and here, let me just write here number of regions, okay, and the number of triangles. Now let's count the number of triangles which consist of only one region. Okay. Excuse me. If it is one, how many we have? 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, right? So we
Yeah.
have 12 triangles which consist of only one region. Okay. And next step is now I'm going to count the number of triangles which consist of two regions. Okay. And how about two regions? So this one is 1, and this one is 2, right? And this one is 3, and this one is 4, this one is 5, this one is 6, and do you see any more?
Oh yeah, on the other side.
Where?
They're like on the left. It should be 8.
7, 8.
And I think that's it.
That's it, right? That's 8. So there are 8 triangles which consist of two regions. And how about 3? And how about 3? 3 may be a little bit
There's
tricky,
4.
but I'm going to use curve. So 1, 2, 3, it is this, right?
Yeah.
Okay. 1, 2, 3, also it is this. All right. 1, 2, 3, also this one forms a triangle. 1, 2, 3, also it forms a triangle, right? And that's it.
Yeah.
That's it, I think. So there's how many? 4, right? And do we have 4 parts?
I don't think so.
Okay. All right. But now we have big ones, right?
Yeah.
1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, and 5, 6, right? Actually, below part. Actually, you can see that, I think. So I'm talking about this A and B and C. Let me just label like this. A, B, C, one, right? A, D, C, another one. A, B, D, another one. B, C, D, another one. How many? 4, right?
Yeah.
So these are the big ones. We don't have any more. In total, we have 28. Right, Ibrahim?
Yeah.
I
Oh, I
mean,
missed the
yeah.
I missed the 3 triangle ones. That's why I got
Yeah. So the big ones, you couldn't see the big one. You saw small ones, but you couldn't see the big ones. Or did you miss the biggest one or the 3 region? Which one did you didn't see?
the second biggest one.
A second biggest one, the 3 regions.
Yeah.
Oh, I see. I thought you didn't see the big one. Sometimes, we see small things, but we cannot see big things. Also, in real life, it is like this, right? Very difficult problem, we can solve it, but very simple problem, we cannot solve this. At work, we have a big problem, we can solve it. At home, we have very small problem. And let's say 2 kids actually fight, we cannot solve this problem. It's something like that. Anyway, we'll continue. 15 and 16, right? Now 17. This statistics question, I wonder why you got different answer. Let's see. Read the question first.
The graph below shows the number of toys Mr. Tan sold in the first 6 days of work of a week. All the horizontal lines are equally spaced. The number of toys sold on Monday was 40% of the number of toys sold on Sunday. If the average number of toys sold during the week was 210, how many toys did Mr. Tan sell on Sunday?
Ibrahim, try again. What do you get this time? Okay, I'll give you 3 minutes because the first time you try, it's wrong. The second time you try, also it is wrong. That means somewhere wrong in your method. But the first time you try it's wrong. The second time it is correct. That means that you made some kind of technical mistake, right? Technical mistake is not a big deal. But if something's wrong in your method, we have to fix it.
I still got 120.
Okay. Now let me just label this.
Yeah. I did use units though. I used U units.
The number of toys sold on Monday, right? So that's 6N, right?
Yeah. Oh, I
Was
see where
this,
I messed up.
huh?
I see where I messed up. I did a Sunday's 40% of the toys on Monday.
Hmm.
Why do I always do this?
Okay, it's Monday. Okay, you want to try again? If you actually made that mistake, it's Monday, right?
Yeah, sure.
So was 40% of the number of toys sold on Sunday. So that is 40%. That is 0.4 of the toys. 0.4. So the 40% of the number of toys sold on Sunday. On Sunday, it is 5N, right? Okay. Come on, Ibrahim, correct your mistake and finish this. I wanted to solve it.
Okay. Oh, I got 525.
525, right?
Yeah.
Yeah, that's
That's
it.
the right answer? Oh, yeah.
Because, yeah, that's correct. So this one is 2N.
And
No, 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 no. Okay, that's not here. So the number of toys sold on that one day was 40%, right? So that is 6N should be equal to 40% of number of toys sold on Sunday. And after that, you can just form your equation and solve it, right? So from here, what is Sunday? So this one is 2 over 5, 5 over 2, right? So that is 3, is it 15N in Sunday?
yeah,
Okay. And after that, we get, what is it? How many toys did Mr. Go sell on Sunday? On Sunday, he
525.
sold 525. Okay, good. The most important thing is if you can see your mistake, that means that you're making a progress. The problem is if you cannot see a mistake, you know, this kind of students always they make the same mistake. 17 and 19, 18, 19. Read the question.
Derek spent 4/9 of his money on a toy, 3/7 of his remaining money on a book, and the rest of this money on 5 cakes, which costed $7 each. How many dollars did he pay for the toy?
How much money in dollars did he pay for the toy? Try again, Ibrahim. I'll give
Okay.
you 3 minutes. Let's see what do you get this time. The same answer or different answer? Yes, Ibrahim.
Yeah, I couldn't get it. Yeah, it's probably my method though.
Look, Ibrahim, the first step, as you see here, in these fractions, denominators are 9 and 7, right? So what is the least common multiple of 7 and 9? It is 63, right? Now, actually, it doesn't matter. I label X or something about his original money. Suppose that Derek has how much money? He has 63 dollars. Right? Because in math, any number, I can write any number as a product of two numbers, right? But instead of like, let's say $10, I'm just writing here 2 times $5. The same thing, right? It just actually facilitates my problem solving. And look, here, Derek spent for ninth of means times his money. How much did he have? 63 dollars, right? On toys. So let me simplify this. 63 divided by 9. 7 times 4, 28. So that means that 28 units of his money he spent on toys, right?
Yeah.
And now remaining, how much remaining now? 63 minus 28. That's equal to 35, right?
Yeah.
So now he has 35 dollars left. Next, 3/7 of means times his remaining money. Remaining money is 35 dollars, right?
Yeah.
So that's equal to 5 times 3, 15 dollars. And now remaining is actually at 28 minus 15, right? That's equal to, no, 35, right? 35. Okay. That is 30, 43. So 35 minus 15. So now he has 20 units of his money left, right?
Yeah.
And now the rest of the money, right? So rest of the money is 20 times X. He spent this money for 5 cakes, where each cake costs $7. Okay, now from this equation, from the last equation, I can find X. What is X? 5 times 7 divided by 20, which is equal to 7 over 4, 1.75, right? That's our first step. And now in the second step, how much money did he have? Did he pay for the toy? Now I'm going to write for the toy. He paid $28. And the value of X is 7 over 4, which is equal to $49. Okay.
Okay.
If you just actually label by X his original amount of money, and after that, still you can solve this, but you'll have to deal with rational numbers. This is just using a little bit of thought. We are making our problem much easier. And that's what we are trying to learn here, the gain this kind of, what is it, experience, right? Continue. All right, 19. Now let's have a look at 23, then maybe 22. This is 23. Read the question.
Which question is this? Oh, question 22. The sum of the sum of ages of Alfred, Betty, and Karen now is 3 times the sum of Derek, Elijah, and Felix now. 6 years later, the sum of ages of Alfred, Betty, and Karen will be twice the sum of the ages of Derek, Elijah, and Felix then. What is the sum of the ages of the 6 of them now?
The sum of ages of Alfred, Betty, and Karen is 3 times the sum of ages of Derek, Elijah, and Felix now. 6 years later, okay, what is the sum? What is the sum of ages of 6 of them now? Give a try again, Ibrahim. 3 minutes, okay? Give a try, and after 3 minutes, we'll discuss together if you didn't get the answer. Did you understand the question?
Yeah. Well, I think my method was right, but I just executed it wrong because I got exactly half of the answer.
Oh, really?
Yeah. Yeah, but I'm
23.
not sure what went wrong there. Let me try again.
Hmm. No, you didn't get the half of the answer. You get the double of the answer, right?
Oh yeah, yeah, double.
Yeah.
I got 72.
72. Now this time
Yeah.
correct. A plus B plus C equals 3 times A sub D plus E plus F.
Yeah.
Okay. And 6 years later, the sum of A sub A, B, C again. So that is A plus B plus C plus 18 is equal to, will be twice. The sum of A sub D plus E plus F plus 18, right? Is it so like this?
Yes.
Okay, very good. So now from the first one, we can just find D, E, F, right?
Mm-hmm.
So you don't have to find A, B, C individually. Did you solve like that?
No.
Like for example, D, E, F, right? And also A, B, C, D, E, F. I know how they're related to each other. Let me just label this, Ibrahim,
Did
by
you do
X,
anything what I did?
by X. Okay.
Uh,
So then this will be 3X, right?
mm-hmm.
So 3X plus 18 will be equal to 2 times X plus 18. If you solve this, 2X move to the right-hand side, it is X. This will be 18, right? So we have to find the sum of their eights, right? If it is 18, right? So this A plus B plus C, it will be 3 times 18. So their sum will be equal to D plus E plus F, 18. And A plus B plus C equals 3 times 18, which is equal to 72. And that's we are just using the power of algebra, just labeling, simplifying, instead of tell me that what are in the box. Well, just tell me that's a box X. I know what it means to me, that's box X.
I used a different method. Well, I did use A, B, C, D, E, and F though.
Hmm.
The, so in, so I just distributed the 3 and the 2 to all of the numbers. So I got the equations A plus B plus C equals 3D plus 3E plus 3F, and A plus B plus C equals 2D plus 2E plus 2F plus 36. Oh yeah, plus 18 on the other side. So I subtracted 18 from both sides, and then that means D plus E plus F also equals 18 if you compare the two equations. And then I just multiplied it by 4.
Okay.
Yeah.
But don't you think this one is much short? You can solve using this method maybe in 1 minute. Because it's a kind of math contest, right way is okay, but we have to find the best way. That means that optimum, right? The optimum solution that says takes the shortest amount of time and fast and less risky, because some method is correct, but the way is risky. You may make a mistake. You may make some technical mistake because it's involving a lot of maybe operations or steps or variables or numbers. So we have to choose a way that actually we use the least number of variables and least number of steps to reach our what is it, solution. That's what we are trying to practice with you. Sometimes just say solution. Wow, we can do that. That's what we need. That's what we are going to develop. Actually, we are going to develop this kind of skill. Think, first look, and compare the methods. Choose which one is the best and less risky, right? And get the answer. Okay, Ibrahim.
Okay.
Ibrahim, I'll show you another paper now from now on. Okay, one paper. If actually we only discuss the mistakes, and after the new paper, okay, in this way, hopefully you will have very strong foundation in math and also your critical thinking skill. Okay,
Okay. Wait,
Ibrahim.
what about question 21? Like I just
21 is about cryptography. Uh, so what did you get?
well, I tried solving it, but I literally had no idea. After a few steps, I just wrote 0 because I didn't know.
0 for DCBA. At why don't you write actual four-digit number? Because DCBA is a four-digit number, right? Right?
Mhm.
You say, for example, the first guess. What do you think about the value of D?
Well, it has to be 1
Huh?
because it has to. Wait, actually, no, never mind.
The value of D must
Like
be
it
1, right?
depends on A, right?
Yeah, actually, this A
Yeah,
times
so it
A
does
is
have to be
equal to
1.
D. So that means that A is not equal to 1, right?
Yeah.
Is it? So A is not
So
equal to 1. If it is not equal to 1, right? So this
B
D,
is
like
1.
1 times 1, it will be 1. Now, if it is 2, for example, let's say if A is equal to 2, 2 times 2, 4, right? And this 2 times 4, it will be 8. That's also not possible, right? If A is equal to 3, for example, it's not possible because 3 times some number, it can be equal to 3, right? So that means that the only choice, if you look at carefully, this A, it must be equal to 9.
Oh yeah, I understand now.
And how about D? It must be equal to 1, right? It cannot be greater
Yeah.
than 1, right?
Oh, and then after you can use that so like 9 times B equals something ending with 1. So then you can solve for that.
But is it ABDD or ABCD?
A,
Wait,
B, D, D.
it should be ABCD, right? Let me just check. ABCD. That's correct. It's not ABCD, ABDD. Also, it can be ABCD, but here it is ABDD. So BDCBA times A is equal to ABDD. Okay. So if A is equal to 1, D is equal to 9, right? Because D cannot be 2, 3, 4, 5. So this will be 1. Okay, I don't know. I don't know yet. This is 9. And I'm multiplying this by 9. 9 times 9, it is 81, right? And also 9 times 1, it must be equal to 9. It cannot be actually something from here. So that means that, what is it? Ibrahim, this number, right? It should be what? Yes. Can it be 2 or 3 or 4 or 5?
No.
No. What is that? Hmm? The only choice for this number, it must be 0, right?
Yeah.
Because it cannot be 1 because I have already used 1. That's why. It cannot be equal to 2 because if it is 2, we have carry over the first digit cannot be equal to 9. So it must be equal to 9. And how about this number? So actually that's equal to 1. And B, right? This is B, and also that is B, right? Only one number left. You can just guess, like for 9 times 9, 81. I have 8 here. It cannot be equal to 0. It cannot be equal to 1. If it is 2, 18 plus 8 doesn't work. 3, it doesn't work. 4, 36, 50 doesn't work. 5, 45 doesn't work. 6, 54, 62 doesn't work. 7, what is it? 63, 81. Okay, it works, right? It's 7. 9 times 7, 63. 63 plus 8 is 71, right? 9 times 0, 0 is 7. It is 7. Okay, that's why this, what is the question here? DCBA, it must be equal to, what is it? DCBA, 1079. Okay, but some
Okay.
cryptography, it's not easy to solve. It takes time. But some actually can just do some logic, you can solve fast.
Okay.
But this one is not so difficult, but just, making some logical guess, you can do that. Ibrahim, that's all right. I had to start another class now. I will send you one link, another test. If you have time, try to finish one test until next week, okay?
Okay.
If you have more time, let me know. All right?
Okay.
All right. Have a nice weekend. See you next week.
You too. Bye.
Bye.